Okay, so this is a problem you wouldn't get in Chem 4, or you might not get it even in Chem 1A, depends on your instructor. More likely in Chem 4 or Chem 1A, they'll go silver nitrate, AQ plus HCl, AQ yields silver chloride, a solid plus HNO3. And when we look at this, oh, we have precipitation here. Here, there's no asterisk. There's precipitation. We're taking two solutions. We're going to form a precipitate. This is a precipitate here. But this is complicated. And so the easiest thing in Chem 4 is never give a problem like this. That way you don't have to explain it, right? But in Chem 1B, we don't want to restrict to a small subset of reactions. We want to be able to handle a situation like this. So how do we know if this is willing? Because take a look at the reverse reaction. If I look at the reverse reaction is precipitation also. So we got precipitation vs precipitation. Precipitation versus precipitation. Which side's going to win? Which side will win? Which side is more stable? Is it precipitation in the reverse or is it precipitation in the forward? If it's precipitation in the reverse, we don't want any reaction to occur because we just want things to stay as is. So Eric, you remember what to do in a scenario like this?
I think chlorine's more stable.
What?
I think chlorine's the AgCl is more stable than HBr because the electron density on chlorine.
Yeah. Yeah, well, that's the way we'd start to analyze it. We'd start to try to figure out which of these two is more stable based on the structure, like you're doing there. That's perfect. However, we need to do additional analysis. We can't just say straight precipitation because we got to figure out which of these two precipitates is more stable. So what Eric was doing is he's saying which one's going to form a stronger bond. So he's thinking chloride has a higher charge density than bromide because bromide's bigger. So the silver chloride bond would be stronger. And normally you'd be absolutely right. That's exactly the way we think about it, except silver is a heavy metal. When we're dealing with heavy metals, the problem is there's more covalent interaction in there. And so we have to worry about the covalent interaction. In fact, this turns into one of these hard, soft, acid-base problems because silver turns out to be a soft cation, and we're looking at bromide versus chloride. But anyway, the point here is further analysis has to be done. And based on just if these were purely ionic, you'd be right. This would be more stable. Silver chloride would be. It's just a trick with the covalent interaction here. But so that we shouldn't use this because then we have to know which one's more stable: calcium carbonate or calcium sulfate. Well, calcium's 2 plus, carbonate's 2 minus, calcium's 2 plus, sulfate's 2 minus. So the charges are the same. Then we look at the shape and the size of the ions. You know, carbonate is a trigonal planar. So we've got a calcium. Sulfate is a spherical or tetrahedral. You know, and so how do they pack together in an ionic lattice? And then we'd see, you know, which one gets closer, which one has a stronger bond. But are we going to do that? No. We could do that theoretically, looking at the bonding of the lattice, or we could do it experimentally by looking up observations. What factual observations will tell us which one's more stable? You know, what I do is I probably, you know, rather than doing this, which would get pretty tricky, I might just consult the CRC handbook or the Merck index and look at which one has a higher solubility. You know, the one that has a higher solubility is less stable, or I'd look up the one that has a higher melting point. The one that has a higher melting point is more stable, you know, and based on that instead. And so I might just do this using factual data and see which one. If it turns out that calcium sulfate has a higher melting point than calcium carbonate, then I'd say it's favorable precipitation. But if it turns out that calcium carbonate does, then I'd say it's probably not favorable. It's the same thing here. What this is called is, this is not called a precipitation reaction. This is called a solid to solid conversion. I have a bunch of silver chloride solid. I want to convert it to silver bromide solid. Can I just add HCl and do it? Maybe, maybe not. It's a solid to solid conversion. And so watch out for those. Okay, so we're going to finish this. You're going to do the ionic equation and the net ionic equation for this one. When we do that, let me just reiterate a couple of points here about acids. You know, all we need is one driving force. So this is a question mark, but I have another driving force. And the other driving force is stronger acid to weaker acid. So HCl versus HBr, which one's stronger, HCl or HBr? HBr is stronger. HCl is weaker. If HBr is stronger, HCl is weaker, then we can just say no reaction. We don't have to know about the precipitate. We can just say that because all we need is one, right? And so HBr is a stronger acid in water than HCl in water. Does that sound right? No, I see head shaking no. Why not? Because of the leveling effect, right? Because of the leveling effect that these turn out to be a tie. Even though when we look at the chart, HBr is indeed the stronger acid on the chart, we need to know about the chart and how to use the chart. Are you using the chart properly? If you're using the chart properly, then you know about the leveling effect. And therefore, all the strong acids are the same in water because the strongest acid that can exist in water is hydronium. We can't have an acid stronger than hydronium in water. So what does this mean? This means that this is a big question mark. We don't know, and this requires further analysis. The further analysis did in Chem 1A. I don't want to do it right now in Chem 1B because it takes too much time. So we're not going to do further analysis for right now because, you know, in Chem 1A, these are all qualitative. In Chem 1B, we're going to take a step forward and do this quantitatively. I can figure out the thermodynamics of this and tell you if there's a thermodynamic driving force by doing some thermodynamic calculations. That's just easier to do. Okay. Versus what we were doing in Chem 1A, which is quite a bit involved, you guys recall. All right, so we're going to finish this, and so do we ionize calcium carbonate? No, we only ionize the strong electrolytes. What are the strong electrolytes? The strong electrolytes are the strong acids, strong bases, and the soluble salts. This is the insoluble salt, so we leave it alone. Sulfuric acid is a strong acid, so we ionize that. What do we ionize it to? Do we ionize it to 2H plus an HSO plus an SO4 2 minus? Is that what we ionize it to? No, this is wrong. We ionize it to H plus and HSO4 minus. What happens is the waters don't do a coordinated attack. You know, the waters don't coordinate when they're going to pluck off the protons. Because remember, H pluses are hydronium. So the water comes in, plucks off one proton, then the second water comes in, and it's going to have a harder time. It's going to have a very hard time. What doesn't happen are two waters, you know, they communicate, 3, 2, 1, attack, and then pluck off both protons at the same time, right? That doesn't happen. And so one plucks off, and unfortunately the second water is going to have a hard time because it's a weak acid. Calcium sulfate, do we ionize it or leave it alone? Leave it alone. Water we leave alone, and CO2 we leave alone. Okay, this is the total ionic equation. Then we cancel out the spectators. There's no spectators, so this is the same thing as the net ionic equation. And then we would be done with this. So once you finish this one, then we're going to go on to the second reaction. The second reaction I'm just going to give you is being silver plus nitric acid. And the third reaction I'm going to give you is sodium I'm going to do sodium, what was it? I have to look it up. We're going to do sodium monohydrogen phosphate plus potassium hydrogen sulfate. All right, why don't you guys work on these? You can work with your friends or neighbors, open book, open notes. Bring these off to me when you periodically for a progress check. Okay. When you're done with these, then these are going to be worth some points. These aren't going to be worth that many points. 1 point, 1 point, 1 point. This is going to be 3 points worth of assignment. Do it on these index cards here. I have extra index cards here and here. So do it on the index cards because it's easier for me to check off on the index cards.